Okay, in this video, we're going to be deploying serverless HTTP endpoints with GCP Cloud Functions. I generally design these videos for you to walk through them with me, so I would suggest that you go to the video description and grab the GitHub link, and that'll take you to this README file, which we can walk through this together. So this video is a follow-up to the GCP Managed Instance Group tutorial, and in that tutorial, we deployed a very simple Python microservice using the Flask framework that talked to Firebase database. And what it did was it stored these names in the database, and we had to set up some scaling rules or scaling policies so that if the VMs got above 60% utilization CPU, it would add units, add VMs. And then if it got below 60% for 5 minutes or more, it would remove units. And so what we're going to do is we're going to deploy a set of Python-based serverless functions using Cloud Functions. Now the goal is to create an API that's functionally equivalent to the API that we did in the GCP Managed Instance Groups. And so I call it tongue-in-cheek in places Flasky. It's Flask-like. It's not quite Flask. It does use Flask objects. It's all in one module, but it's not quite Flask, so I call it Flasky, sort of tongue-in-cheek. And so by the end of this video, you should be able to know how to deploy Python-based HTTP endpoints as Cloud Functions using Terraform. And so what we'll cover is actually building that Python code into Cloud Functions. We're going to use Firebase as the document database. The first time we deploy this, it's going to be deployed on the public internet with no security, no authorization. And so we'll do that. We'll show the API how it works. And then we will secure those HTTP endpoints with JWT token authorization, which is a variant of OAuth OIDC, and that's how we'll secure them. And then at the end of the process, we will clean up all resources and be good stewards of our cloud environments. So what is serverless? I guess there's three key characteristics. The first one is the whole what does serverless mean. It does not mean that there's no servers. There obviously is servers. You don't manage the servers. Google manages the servers. Underneath the cover, all this stuff runs as containers. When you deploy the code, GCP is deploying containers. So it handles the provisioning of the servers for you. Another way to think of this is Cloud Functions is the smallest and cheapest amount of compute you can buy from Google. Essentially, you give Google some code, in this case Python, but this supports all sorts of things like Go, Java, .NET, maybe PHP. Have to be sure which ones support PHP. But the idea is you give it the code, and then the system, Google, will invoke the code from various triggers. Now, in the case of this example, the trigger is HTTP endpoints. But these types of cloud functions are used all over the place for event processing, stream processing. It's sort of the glue that binds a lot of services together. So it's not just HTTP endpoints, but that is a very simple use case that we'll cover. Now, another key attribute is automatic scaling. The Google collections scale up and down based on demand and load, and that is very different than the managed instance groups one, where we had to explicitly set up the rule of 60%, and it would manage it for us, but we had to set that rule up. It does it automatically here with these serverless cloud functions, and then it's pay as you go. When we did the managed instance groups, we had these VMs with these really small APIs, and we're paying for that VM up all the time. Here, we're just paying when our code actually gets invoked, number of requests, execution, and memory allocation. And so it's much cheaper, particularly in these sandbox environments where, if you look at my Google account on this one, it hasn't even cracked $1 after I've been working on this for a while, because it's just so cheap. So let's talk about the actual topology of what we're building here. Within a project, we are going to do the three endpoints, or three cloud functions: good to go, candidates, and candidate. And candidate handles post and gets, which is a little bit different than the other environments. And this is because we opted not to use an API gateway. sort of the ethos of Google Cloud is to keep the simple things simple. And so the things that I would need an API gateway for, like authorization using OAuth, more advanced logging, more advanced routing, I didn't need it for this simple case. So I'm kind of going with GCP's idea of keep things simple. So I kept this implementation simple. It's the simplest of the easiest one, but I didn't use the API gateway to keep it simple because these cloud functions attached to a project gave me everything I need. Alright, so to run this project, there's a set of prerequisites you need. And I have a video out there called GCP and Terraform Easy Setup. You've got the Google Cloud account, obviously. You've got the gcloud CLI. You need Terraform. You also need zip to zip up the functions, and that's included in the check env script. And so this is all you need to get started. Now, I'm assuming you have set this all up. Now, GCP is a little bit different in that, the other environments, there's a series, or the other platforms, there's a series of environment variables that you set for the build so that you can log in. Here, you need this credentials JSON, which is you get out of the console, and that's what you need to connect. And so we'll see that when we do the build. We'll have to first upload a credentials.json. Okay, now we're going to resume doing the build. And so what I want to do is I have a Ubuntu development environment. I'm just going to copy this code into that, and that will pull it down and send a directory, put me in the right directory. So the first thing I want to do is run check env, and just go, hey, you don't have credentials.json. So what I'm going to do is I am going to upload from my laptop credentials.json. And now let's do check env. Alright, now I need to enable the API that I need for this project. And I use a script on that API setup. So I'm going to run that. And then I'm going to give it about 4 or 5 minutes to make all those APIs enabled. Okay, those APIs are enabled. And now we're going to run apply. And while it's doing that, let's go back to the documentation, and I'll basically give a run through of the build process. It's more similar to the AWS build than the Azure build. The first step is we package up the Python code, we zip it into a zip file, and we're going to use a checksum on the zip file to detect changes. So like AWS, we use a checksum. If I make a code change, I rezip it, checksum's going to be different, it'll pick it up and reapply. Now, after that's done, we deploy the infrastructure that we need to actually service up the cloud functions. And so we need a storage bucket for the code, which is more like Azure than AWS. Azure, you have to explicitly give a storage account. Here you need a storage bucket. And then we deploy the cloud functions, and we assign a role to the cloud functions to allow them to access Firebase. Now, the first time we deploy it, it's deployed publicly anonymously. Anybody can hit the endpoints. And then after we finish the build, we do the validate sh, and it should tell us if our API is working properly. So let me go back here, and it is still building, so we'll pause for that. Okay, the build is complete. So it ran validate, everything passed. So I'm going to go and copy this guy right here, and let's go into a new web browser and hit that and say, okay, it's up and running. Good to go is running. So we see the good to go endpoint. So now what we're going to do is we're going to go into the GCP console, and we're going to take a look at what we got built. So in the console, the first thing we're going to do is cloud run. And this will show you all your cloud functions. And so I'm going to click on GTG. Alright, once I'm in GTG, I'm going to click on source. And you can see it's all one module, so it's more like the Azure example. We're using Flask for the response objects. And so I'm going to do a couple of things. First, I'm going to say, I'm going to change this to, I got to edit source code. And this is, in AWS and GCP, you can make these little quick modifications in the console. Doesn't allow you to do it for Terraform derived function apps. So this is, different than Azure. So I'm going to hit that, hit save and deploy. Now the thing you'll notice is these things probably don't pick up very quickly. There's these server-side caching. So everything when we make a change, it takes like a minute to pick up. So I'm going to hit pause and let it catch up. Alright, after a few minutes, the service will rebuild and your cache will get busted, and you'll see, hey, modified is now true. So that's pretty much it. The other thing I was looking at is the candidate endpoint, and that's where it's a little bit different. The other ones is I handle it in the code. I say if it's get or a post. This is a sort of another artifact of not using API Gateway. API Gateway could do more advanced routing. So, I was just trying to keep things simple, but that is a difference between this and the way we would work with API Gateway. So now let's go into Postman and let's take a look at these APIs. So what I'm going to do is I'm going to copy this URL, go into Postman, and say get. We'll send that, and we should get the modified one with true. And so that's the first endpoint. The next endpoint is candidates. And you can see I've got a bunch of candidates here from previous runs. And so I also have the candidate, and I can say homie1. So that's the third endpoint. And then the fourth input is a post. And that's what I'm going to put, just put Mike. And it should add Mike. And then if I go back to get and say candidates, you'll see I should have Mike in here somewhere. So those are the 4 endpoints. And notice that these are valid anywhere. If you're sitting at your desk now, you could hit these endpoints if they were up at the right time. So there's no securing them whatsoever. So the next thing we're going to do is we're going to walk through securing them. So let's go to the documentation, and there's the instructions here how to do that. We've covered the good to go endpoints. So now what we need to do is we need to modify the anonymous variable. So let's go to our code and let's say to 0.1 cloud functions, and let's do a nano variables.tf. And let's go all the way down. So now one thing I'd point is we use a feature called Terraform for each looping in here. So we actually define the functions here in this data structure, and the Terraform code actually iterates through the data structure and creates one for each one. So it's a way of doing a little bit of code reuse. Eventually we'll get to doing some modules, but this is sort of a one way of making it so your code's just not copy and paste, copy and paste. Modules are a more advanced version of that. And then you get to the end here. And so this is where we want to say, we want to change this to false. Save it. And over here, and then what we want to do is back up one directory, because you got to run from the main directory. And we're going to do apply, and it's going to, first thing, it's going to redeploy that zip code. So that modified thing that I made earlier, that's gone. That's going to be replaced because it's not in my source repository. But it's going to rezip the file, turn off the anonymous functionality, and require the header. So I'm going to hit apply, and it takes a moment to do this, so we'll pause. Okay, so the build succeeded, and it went ahead and made those changes. Now you'll notice everything's still passing. And the reason because of that is we talked about when we made the code change for the modified text and the good to go endpoint, that it took a minute. And so it's the same issue here. Is there server-side caching going on? We got to wait for that cache to expire, then this thing to be redeployed with authorization turned on. So we will wait for that. Okay, so we waited a few minutes. Validate, unvalidate, and you say it's all forbidden because we've removed that anonymous access. So now we need to figure out how do we actually call it. And so there's this token here which you have to put in an authorization header. So we'll go back to Postman, and we'll go back to GTE details equals true. And now when I run it, it's going to say forbidden. And so what I need to do is I need to go to the authorization header, and I'm going to change it to be API key, and the key value is authorization. And then what you want to do is go to this guy here. You got to be very careful because it's trying to trick you to copy and paste this. If you forget one character, it's invalid. Now, there's generally toolkits associated with doing with this. And also, this bearer token is only valid for like an hour. So even if this function, this value would leak somewhere on the internet, it is a very limited time frame where you're compromised. You're still compromised, but it's a more limited time frame. So I think in grand scheme of things, this is probably the most secure of all three of the cloud native ways of securing your APIs because it's really a variant of OAuth. So let's go and copy that and put that in the header. And now let's hit send. And you can see I'm now calling the API correctly. So if I take the authorization back, it'll remove it. So now I could go and do candidates. And I get that list again. Again, all keyed on this authorization. And this key is only valid for an hour. So there, like I said, there's toolkits associated with this framework where you can not have to do sort of the manual copy and paste, where you can actually say, okay, here's how I authenticate, give me a bearer token. So that's pretty much it for the code. At this point, you want to be good stewards of your cloud accounts. So I'm going to do destroy. And while it's working, I am going to go to the GCP specific things from this. The first one is the keep things simple mantra that GCP seems to have. Is yes, there's an API gateway, but for this very simple case that we had, cloud functions with automatically attached HTTP endpoints, they give me everything I need. Now there's, I probably could do better routing with that candidate endpoint where I check for get and post. But like I said, I was trying to keep it simple because that's what that's what GCP tries to do, keep things simple. Eventually, I think I'm going to do a video with how we connect these APIs, these serverless APIs, to OAuth with like a Okta or Ping ID. In which case, when I do that, I will most definitely have to add an API gateway to the solution to be able to support that. The second thing is a storage bucket is needed, just like Azure. So when you define your your cloud functions or your Azure functions, you have to say, okay, you have to explicitly set up a storage bucket or a storage account for them to store. The third thing is dealing with API management. That's unique for GCP. You have to run the API setup. I typically don't do that in the Terraform code, or if I did, I would do it in another Terraform code. I wouldn't do it in the project code. So that is something specific to GCP. We also notice when we change things, it took a while. It takes like a minute or two for, like, if I change authorization for the caching to get busted, or even making a small code change. You can make code changes in the console like AWS. Not recommended to do that, but if you just need a simple, quick and dirty, let me try this one thing to see if it fixes, you can do it. Although I think that's probably out of the ordinary for ongoing development. And then finally, I would give the way it does the security API the cloud native way with the gauth header is probably the most secure of the three. The most secure would be, in my order, would be GCP with the auth header, AWS with the, we use the AWS v4 signature with a user ID or access key and secret key, and then the one that's least secure, my money would be on Azure Functions. The function key stuff is not as robust as the other two. So this is the last one in the series of serverless HTTP endpoints.